Assalamualaikum and good morning, everyone. Thank you very much for inviting me to share in this international symposium. Please allow me to share my slides. Can you see my slides?
Yes, we can see.
The topic that's been given to me to share this morning is about data analysis and result reporting using a PLSM approach. And I think this is one of the topics that people hate most because it's a bit technical, but I'll try myself to make it as layman as possible to make sure that most of us can understand, even though actually it should take a lot of time to learn about PLSM before we discuss about reporting. Maybe my audience here, some of you have already used PLSM, various software available for PLSM, and maybe some of you are beginners, especially for undergraduate students who are joining us. So the focus is not on using PLSM, but it's more on how to report or how to read papers presenting PLSM results. So what this session is all about, before we move on about reporting, I will share with you about PLSM a little bit, the introduction of PLSM, and then we are going to touch a little bit about why we should use PLSM. And the main focus of this discussion today will be on how to report and how to understand, for those who are new with PLSM, how to understand a result from PLSM papers. And then the most important thing, this session is not about how to use any PLSM software. Okay, first of all, what is a PLSM? Okay, basically researchers in social science have been using many statistical applications for the purpose of data analysis. And then initially, they've used univariate and bivariate analysis to understand the data and to understand the relationship between data. In this slide, we can see the difference between univariate and bivariate data analysis. For univariate, normally we just analyze a single variable. For example, like gender. What we want to know is how many male, how many female, so we can calculate maybe in terms of frequency, in terms of the percentage of male in the group or female in the group. And then for bivariate data analysis, we can go for more advanced analysis by looking at the relationship, for example, looking at the influence or effect from one variable to another variable. And that, the limitation is only one variable influencing another variable, meaning just two variables involved. So we can use a bivariate data analysis. So if you want to learn more about this kind of univariate and bivariate, you can look into this video link here. I put it here. And then what happened if there are more than two variables involved? Because nowadays in research, people are developing more complex model because there are so many predictors so many determinants that can influence our interest variable. So, for example, like this. Meaning in this example, you can see, for example, I think many of us may be familiar with this theory, theory of plane behavior, developed by or introduced by Isaac Eisen. In this theory, you can see it has three predictors, one mediators, and one outcome variable or dependent variable here. So for this kind of model, we need more advanced application to analyze the data, and therefore we need to use multivariate data analysis method. So what are the methods or what are the techniques available for multivariate data analysis? The statistical method that can be used to analyze this kind of data, the complex model like this, can be divided into the purpose of the study. If the purpose of the study is more on exploratory, we have first generation and second generation technique. First generation, we can use, for example, exploratory factor analysis, for example, to understand the different factors involved in the model. And then for confirmatory, we can use, for example, multiple regression, for example, on logistic regression, for example. And then more advanced technique is now available. Previously, in a PLSM, the well-known technique is CBSAM. This is a strong technique already that has been established. And since 2010, the popularity of PLSM or PLS path modeling, another name for PLS-SAM is PLS path modeling, PLS structural equation modeling, or it is also known as variance-based SAM. So the focus of our discussion today will be on looking at the reports from the data analysis by using PLS-SAM. And then these are the examples of package or software that we can use to analyze data by using PLS-SAM technique. The quite user-friendly software among here will be the Smart PLS. It could be PLS Graph, and other than that, it's a strong software, but quite complex. It's R, for example. Okay, the next, why we use PLS-SAM? In this slide, you can see some proposal or recommendation on why, the reason why we should use PLS-SAM. The first one, when analysis is concerned with testing theoretical framework from prediction perspective, because PLS-SAM is now becoming a more powerful tool to analyze predictive power of a model. And then number two, if your research framework is involve many constructs, you can see in this small picture, the blue circle here representing construct or latent variable. That is the factors or the variable that you are interested to measure in your study, maybe to know the relationship and the influence of these variables. And then other than this variable, there are so many questions involved, or we call it also indicators. A question that you give to your respondent to answer is represented by these yellow boxes. One yellow boxes representing one questions that your respondent need to answer. Meaning if you have many construct or many variables many latent variable for you to measure with many items or question item to be given to your respondent for the analysis. PLS SEM is one of the suitable technique to be used. When the research objective is to better understand the increasing complexity by exploring theoretical extension established, that is for exploratory. For exploratory research, exploratory also mean that you want to extend the existing theoretical framework, or you want to integrate a certain theory, or you want to decompose certain theory, so you can use a PLSM. And then when the path model includes one or more formative measure construct. Formative measure construct meaning some construct here or some latent variable here, depending on the, we call it measurement theory. Some measurement theory for certain construct certain construct is measured based on reflective, we call it a reflective construct, and some measured are formative construct. We will talk about this later after this. And then when the research consists of financial ratio, also we can use this one. And then when the research based on the secondary archival data, also we can use PLSM. When small population restrict the sample size. For example, in the business environment, sometimes the number of companies in terms of the population itself is very small. For example, maybe you want to find out a number of 5-star hotel. 5-star hotel itself is very small. And then when we send a survey, the response rate also very, very low in terms of the response rate. So sometimes very difficult to analyze a small sample size, a small sample by using other software. PLS can help with that. And then when the distribution, this is also one of the main reason or justification for why people use smart PLS, because sometimes ideally we need normally distributed data, ideally, but in practical sometimes it may not happen. So if our data is not normally distributed, so PLSM have no issue on analyzing this kind of data. And then research that require latent variable. Latent variable mean latent variable sometimes is called as construct. That is a variable that is subjectively measured, that we cannot measure directly. We need to measure that variable by using numbers of indicators or number of questions to measure it. So that is what we call as latent variable. And PLSM is one of the suitable or appropriate tool to measure latent variable. And then for more discussion about when to use and when not to use PLSM, you can refer to these papers. Okay, to show that PLSM is more popular, becoming more popular in the research, we can see now PLSM is now widely applied in many social science disciplines. You can see here in the area of accounting, in the area of construction management, entrepreneurship, family business, higher education, hospitality and tourism, human resource management, everything here has, including supply chain management, software engineering. In this discipline, people have used PLSM to analyze their data. And then the number of papers published in flagship journal also have increased dramatically. You can see from in this graph from 1900 to 2015, more than 60 papers have been published, and nowadays it's already 2022. Of course, the numbers have increased a lot. So these are the changes, new things or new development in PLSM. We are not going to discuss in detail about this, because our focus will be more on reporting. Just I want to highlight that previously people says that PLSM should only be used for exploratory research. However, latest literature saying that PLSM is a direct competitor to VBSAM already, because PLSM can also be used to analyze data for different type of research, including confirmatory research, explanatory research, and predictive research, especially with the newly introduced measure for predictive power. That is we call it PLS Predict. PLSM is now becoming more advanced tool to predict, to analyze, to determine the predictive power of a model. Okay, now we are in our main discussion for this session. That is about how to report, and for undergraduate students who have not been using PLSM software, who are new with PLSM, I will show you how to read PLSM papers so that the results presented from this paper can be used to support your final year project or your undergraduate research project. And the main reference for this method of presenting PLSM result refers to method that is being proposed by Hare et al. 2019 in their paper on when to use and how to report the result of PLSM. And then from here, in the figure here, you can see whenever we want to use PLSM, first of all, we need to consider why we need to use, or why PLSM is considered suitable or appropriate for our data analysis. It can be because of sample size, statistical power, the goodness of fit, and distribution assumption, and the secondary data if we use it. And then to analyze it, we have a two-stage approach. The first one, we call it as measurement model assessment, and the second one, we call it structural model assessment. I will explain in detail after this. And these are the primary consideration of using PLSM. I think I will not be explaining this part in detail because we have a limited time. The focus will be on the reporting. So before we discuss about how to report, let me introduce for students who are new with PLSM certain basic terminology, because if we don't understand the basic terminology here, it will be quite difficult for us to understand results are presented in PLSM papers. Okay, from here you can see this is the research model that normally that you will develop in your research project. Maybe you have been introduced with independent variables, dependent variables, mediating variables, moderating variables. In this slide, you can see the Y1 and Y2 here, we can call it as independent variable. Or in PLSM, independent variable here is also called as exogenous variable. Sometimes when you read PLSM papers, you will find this term. Actually, exogenous variables refer to any variables that does not have any factors or any variable influence them. Meaning they are influencing other variable, but no other variable influencing them. So these are considered as exogenous variable. And then Y3 here, Y3 here can be endogenous and also can be exogenous. It is considered as exogenous because it influences Y4. It has an arrow goes to Y4, meaning it may have influence on Y4. And it also influenced by Y1 and Y2. So it is considered as endogenous, meaning it's a dependent variable to Y1 and Y2. Y4 is the dependent variable for Y3. And at the same time, Y3 is also independent variable for Y4. So that is the term, endogenous and exogenous. And then when we want to analyze data in PLSM, normally we have two-step or two-step approach. The first one, we need to measure what we call it as a measurement model. In this model, you can see the relationship between the indicators to the construct. Here, X1, X2, X3 until X10 here, we call it indicators or items or manifest variable or observed variable, or in other layman language, we call it questions, question item that we give to our respondent. For example, we give a survey question to our respondent. How many questions available in the survey, excluding the question asking about demographic profile? So that question represented by these boxes here. If we have 10 questions to measure our variable, we will have 10 items here. For example, here, there are 3 items, meaning 3 questions that is used to measure variable Y1. And then there are also 3 another question that is X4, X5, X6 that is used to measure Y2, variable Y2, or we call it the construct. Here for Y3 also we have 3 items or 3 questions to measure Y3. And for Y4 there is only 1 question. That can also be possible to use, we call it single item measure to measure a single construct. Even though that is not advisable because the more question, the more item is used to measure a construct, it has more quality to represent that particular construct. Okay, so I hope at this stage you understand already what is this. This is represent item, question item. This is represent the oval form here representing construct or latent variable that we want to measure. And then before we analyze, to know the influence or the relationship or the effect of one variable to another, we need to test in terms of validity and the reliability of our measure, the validity and reliability of the question item that we use. Okay, that is the first stage. That is why we call it measurement model. The process is called measurement model assessment, meaning before we analyze the effect of one construct to another, we want to know whether the tool that we are using, the instrument that we are using, the questions that we are using, is it a valid question? Is it a reliable question that we can use to measure what we want to measure? So that is the first step. Because if we use instrument or questions that we prepare, the questionnaire that we prepare, we give to our respondent, if the question itself does not measure what we want to measure, when we get the data later, when we analyze the data, the result could be misleading, because even though the result that we get later showing significant results, however, it may not representing what we want to measure. That is why the first step is to determine whether the question or the instrument that we use are valid and reliable or not. So how to go about it? How do we measure the validity and reliability of the instrument, of the question that we are going to use or that we have used in our survey. Okay, I'd like to take example like this. When we talk about validity. Okay, let's say when we want to measure, let's say body temperature, when we ask people, what are the valid instrument that we can use to measure body temperature? Maybe some of you will say it will be a thermometer. It can be a traditional thermometer or the latest one during the pandemic. That day we used the pistol type of thermometer, right? The infrared, I think. They use that kind of thermometer. Is more accurate. So when we ask people, is it thermometer is a valid instrument to measure body temperature? Maybe expert will say yes, we can use thermometer to measure body temperature instead of using let's say ruler, for example, ruler or measurement tape, for example. Measurement tape, we cannot use measurement tape to measure body temperature, but measurement tape maybe we can use to measure the height of people, for example. And what are the instruments that we can use to measure body weight, for example? Or maybe we can use a weigh machine, a bathroom scale, bathroom weigh machine. So we step on that weigh machine, and then we can read whether to measure how much weight that we have got recently, maybe in terms of kilograms, for example, the scale used. So weigh machine, we can say is a valid tool to measure a body weight, but not a valid tool to measure body temperature, for example. There are so many other instruments that we can use to measure what we want to measure, because that is an observed variable. How about when we want to measure unobserved variable, or we call it latent variable? What tool that we can use to measure, for example, satisfaction? Is there any instrument like thermometer or weigh machine or a device to measure people's satisfaction level? That is not available so far. So what is only available to measure people's perception, people's satisfaction, for example, is the instrument what we call it is as the question just now, the questionnaire. So that is why before we use the questionnaire to measure people's perception, people satisfaction, for example, people's attitude. So we need to check, we need to determine whether this measure is valid or not. So that is why one of the method under, we call it methodological remedy to test for validity is for face validity and content validity. You can ask an expert in this area, in the area of related study, to look into your questionnaire to get their feedback and opinion whether the questions that you use is really measuring every single construct in your model. So maybe some of you have heard about some method, we call it as a card sorting method. There are so many methods available. So that are some procedure that we can use before the actual data collection to check the validity of the instrument that we want to use in measuring our construct. And then after we have distributed the questionnaire, assuming now, I don't want to talk about the methodology on testing on in terms of a methodological approach on testing validity and reliability. The focus here will be on the statistical approach on testing validity and reliability. So other than a methodological approach, we also have a statistical approach on testing validity and reliability. Assuming that you have measured, you have determined the validity and reliability of the instrument that you want to distribute to your respondent. After you distributed the final data, and then you have got the response from your respondent, and now you want to measure how do we measure validity and reliability of the instrument that we have used. Okay, let me show you. All right. Okay, here this is another example. Another example that I showed you just now. The relationship between the construct and the instrument. For example, you can see here. Let's say COMP here representing competence. Meaning you want to see, is it competence have any relationship or effect on CUSA? CUSA here representing customer satisfaction. You can see here, competence represented by 3 items. Meaning we have 3 questions to measure competence. Comp 1 here represent this is example of the question. And then for likability here also 3 items, and these are the item or question that we use to measure. And this is how PLSM model is developed. Okay, so whenever we have collected data, before we analyze to see whether the influence of one construct to another construct is significant or not, as I told you just now, we need to check on the validity and reliability of the instrument that we have used, or validity and reliability of the data that we have collected. It can be measured by looking at the certain measures that has been determined by expert. It depends on the model. Some of our model, we call it as reflective model. Some of our model is called as formative model. So what is the difference between formative and reflective? If you look at this slide, some construct, for example here Y1, this is what we call as reflective model. It also have 3 items to measure Y1. And then normally the items here is quite related, meaning the construct of Y1 is reflected by these 3 items. Compared to formative model, Y2 for example, it is measured by these 3 items, which is normally different from one to another. They are looking at different angle to measure Y2. So that is what we call as formative model. And how do we know that the construct that we are measuring is reflective or formative? This one is based on our readings on existing measurement theory. So that is why it is not simply put the arrow as a reflective or arrow as formative. We need to find papers using the same construct that we are going to measure to see whether they are reflective or formative. That is why in PLSM we need 2 types of theory to support our model. One we call it as measurement theory, and second one we call it structural theory to support the relationship between one construct to another. Okay. Okay. In this slide, you can see the example of measures that we can use to determine the reliability and validity of the instrument that we use in our survey, for example. First, we look at the indicator loading. Indicator loading must be more than 0.708. And then second one, indicator loading is to look at the consistency of the indicators to represent the construct that we are going to measure, and then to know whether the indicator is a valid indicator or not, the loading must be 0.708, because if we square the indicator loading, we will get at least, it must be here for 0.708 square, it will get at least 0.5, meaning more than half, more than 50% of these indicators representing the construct that we are going to measure. And then the second step here is to look at the reliability. Reliability means for example, like when we use a thermometer just now, I told you, we want to know the thermometer is we agree already that a thermometer is a valid instrument to measure body temperature. That is valid. However, other than the validity, we also need to look into the reliability. Is it the thermometer is reliable or not? Sometimes the instrument is valid but not reliable. What reliable means? Reliable means sometimes when you use that thermometer to measure body temperature for one person, the first time you measure using the same temperature, maybe the temperature is 37 degree. The second time, 38 degree. The third time, 35 degree, meaning 3 different readings, assuming that all other factors remain equal. But you got 3 different readings, meaning that instrument is not reliable. Reliable instrument meaning every time we use the same instrument to measure the same phenomena, we should get the same readings, the same answers, the same result. So similarly for internal consistency, we want to know how consistent the instrument that we have used, the question that we have developed, the question that we use in our questionnaire, how consistent this question in measuring the construct that we want to measure. So it can be represented by 3 different approach to show the reliability. Normally, traditionally people use Cronschbar alpha, and then another alternative, we call it a composite reliability. Actually, Cronschbar alpha is quite strict in terms of measuring the reliability. Compared to composite reliability, is more lenient. Meaning when we use composite reliability to measure reliability, normally the score will be higher than Cronschbar alpha. Even though they are measuring the same thing, because of that, scholars have developed another measures for reliability is called rho A, reliability coefficient rho A. Rho A is a fall in between. So to show whether your instrument is reliable or not, you can use either one of these. And it is recommended to use composite reliability and rho A instead of Cronschbar alpha. And then the score should be 0.7 and above to show adequate reliability. And for exploratory research, above 0.6 is acceptable. And then the recommended value is between 0.8 to 0.9. This is for reliability. The next one, we want to know whether the instrument that we use are valid or not. So in terms of statistical approach, we can show the validity of the instrument by looking at the average variance extracted to measure convergent validity. Okay, here is used to show whether all the item that we use to measure a certain construct converge to measure that particular construct. If the AVE is more than 0.5, it means that it's a valid measurement for that particular construct. And then finally, we also measure discriminant validity. Discriminant validity is used to measure, to differentiate the measurement item that we use in our questionnaire, meaning a certain group of question is used to measure IV1, for example. Another group of instrument of item is used to measure IV2, IV3, IV3. Meaning the item that we have used is measuring different construct in our model. So to test whether they are discriminant to each other, we can use a cross-loading last time. We can also use our Fornan and Lacker or the newly developed measure around in 2015. People have developed HTMT, heterotrait monotrait measure, to determine validity. Okay, before we move on structural model assessment, okay, let's see one of the example in papers. Okay, look at here. In these papers, we have hotel. How many construct here? We have 1, 2, 3, 4, 5, 6. 6 construct. 6 construct. This paper is about hotel website quality. To look at the relationship or the influence of website quality on perceived flow, on the customer satisfaction, and then the purchase intention. How do hotel website quality influence perceived flow? How perceived flow influence customer satisfaction? And how perceived flow and customer satisfaction influence purchase intention? And then in this model, they have used a hierarchical component, or we call it first order and second order construct. To measure hotel website quality, this construct is measured through 3 different dimensions here. Okay. So as usual in other papers also, other than PLSM, every paper, the first of all, we need to represent the demographic profile of the respondent, and then after that, normally in PLSM papers, you need to present, we call it a table like this to show the validity and reliability of the instrument that we have used. Look at here. There are 1, 2, 3, 4, 5, 6 construct that has been measured just now, and then every single construct here will be measured by certain number of items or certain number of questions that we give to our respondent to answer, right? Okay, for example, here hotel website quality is measured by using 1, 2, 3, 4, 5, 6 questions. And then to know whether this question is reliable and valid or not, to represent hotel website usability, whether the question is a valid question or not. To represent hotel website quality, we look at the loading. Loading here should be more than 708, right? Because if they are more than 708, meaning they are at least representing 50% of the hotel website quality. So here, based on our threshold value just now, for loading, it should be more than 708. Here we can see all loading are more than 708, except for certain, this is more than 06. More than 708, that is acceptable in exploratory research. And then the second one, when we want to look at the convergence validity, we look at the AVE, whether the instrument that we use here is valid or not, for every single measure, valid or not, to represent every single construct here. We look at the AVE, and AVE here should be more than 0.5, meaning this is a valid instrument to measure every single construct in this study. And then here we, for reliability, the author have used composite reliability. From the table just now, we can see we have three measures, right? We have Cronchbar alpha. Normally students use Cronchbar alpha if they use SPSS to show the reliability. Here, the author have used composite reliability instead of Cronchbar alpha and row A. Okay, look at here. The Cronchbar alpha value here is all higher than 0.7. This is 0.9, 0.8, 0.8, 0.9, 0.9, 0.9. Meaning all higher than 0.7, meaning in this study, all instruments are valid to measure every single construct that this study is measuring. So whenever we have reached, whenever the validity and the reliability have been satisfied, then we can go to the next. There is another step that we need to do, is to look at the discriminant validity. Discriminant validity is to show how the question item that we have used to measure discriminate from one to another, meaning one question are not measuring the same construct or are not measuring two different constructs. That is the meaning of discriminant validity. How to determine whether the discriminant validity is established or not, we can use, if you can look at the measures here, we have three different alternatives. We can use cross-loading, Fornan and Lacker, and HTMT. According to Hare, HTMT is more powerful, much better measures to determine discriminant validity. Even in their papers, if we use HTMT, we can ignore cross-loading and Fornan and Lacker already. But some author, depending on the editor and reviewers, some reviewers want to see Fornan and Lacker as well. Some author also want cross-loading. So it is up to the reviewer and the editor. At least one of the measure must be represented. For example, in this paper, cross-loading is not used to measure discriminant validity, but the author used Fornan and Lacker, and as well as HTMT measure. Okay, let's take a look at the threshold value just now. For HTMT, look at here, the threshold value, HTMT should be less than 0.85. Based on the result here, all the HTMT value for every single construct are all less than 0.85 here. So meaning discriminant validity has been established. Another method is by using Fornan and Lacker. If you look at here, Fornan and Lacker, how do we read Fornan and Lacker to show whether it is showing adequate discriminant validity or not? We take a look at the diagonal value here. For example, here for perceived flow, this is the square root of AVE actually, square root of AVE. Look at here, for example, AVE just now for perceived flow. AVE for perceived flow, the AVE score is 0.806, right? 0.806. So the square root of AVE for perceived flow here, it will be 0.898. You just use your calculator if you want to check the figure. Just square root AVE, you get this figure. And we need to compare every other construct. The correlation matrix here must be lower than the square root of AVE here. If you look at here, all the other correlation metric here are lower than 0.898, meaning similarly for SP here representing for security and privacy, 0.803. Where do we get this figure? 0.803. Of course, the software will show this figure, but if we want to double check, it is a square root of this one. The square root of AVE here for security and privacy is 0.645. The square root you will be getting 0.803. And all other construct, the correlation metric should be lower than this. If all correlation metric here lower than the diagonal here, the diagonal value here, meaning the discriminant validity has been established. So whenever the convergent validity using AVE and discriminant validity has been established, so the next step we can use to determine, we call it to go for structural model assessment. Structural model assessment is used to determine, basically to test our hypothesis, whether it is supported or not. So basically, these are the measures that we need to determine for structural model assessment for collinearity, VIF, And then to show at explanatory power, we can use R square. For predictive power, we can see predictive relevance or Q square and PLS predict, the newly developed measures. And then also we can search for path coefficient, present path coefficient and the significance of the study. And if we want to do model comparison, we can also use model comparison approach later. Okay, now these are the threshold value for to determine collinearity by using VIF, and this is the threshold value for coefficient of determination or R square to represent explanatory power of the model. And then another measure that is option. This is optional whether you want to report or not the effect size. If the editor or reviewer requests you to show the effect size, you can also report, present the effect size, and these are the threshold value. And another one to test the predictive power of the model, we can use Q square or predictive relevance, and this is the threshold. And then another one is a PLS predict. Maybe in this session we don't have enough time to discuss in detail about PLS predict. And then the focus in this session will be on a path coefficient and the significance of the relationship. And this is the standard threshold value to determine significance level, depending on whether in the analysis we use a single tail, a one tail, or two tail test. Okay, let's see the example of this paper just now. Okay, from here, normally we need to present the result of our hypothesis, and we need to show the hypothesis that we are measuring. For example, in this study, it has 4 hypotheses, H1 until H4. And then the column 1, it is recommended you put the hypothesis number here, because of some paper they don't put the hypothesis number, so it's quite difficult for the readers to know the path model. The path here is for which hypothesis. For example, here for H1 is here the relationship or the influence of website quality to perceived flow. So how do we know the website quality significantly influence perceived flow or not? We need to present the beta value here. And this is the direction of the relationship. Normally, for students who are new with a path coefficient, this is what we call a path coefficient. The relationship between one variable. When we want to measure the relationship between one variable to another variable, we call it a path coefficient, and we represented by beta, or we can also call it as beta coefficient. And the beta coefficient, if you look at here just now, for path coefficient, the value between -1 to +1. And -1 represents perfect negative effect or negative relationship, where positive 1, this should be +1. Positive 1 represents perfect positive effect, and if there is a 0, meaning no effect at all, or no relationship. So here we can see the relationship between hotel website quality and perceived flow represented by 0.519 or 51. You can say 51.9%, the effect. And then to see whether this effect is significant or not, we can see the t-value score. Some paper present t-value, some paper present p-value. So how do we know? We need to compare the t-value score given here or provided here based on the threshold value. Here the threshold value, also known as critical value, is 0.258. 258. So here is 14. The t-value for H1 is 14.824, much higher than 258, meaning the relationship or the effect of a hotel website quality on perceived flow is supported, meaning that this is significant relationship, significant effect of website quality on perceived flow, and the effect is the relationship is a positive. There is a positive effect, meaning the higher the website quality, the higher the perceived flow. Even some paper, they don't show whether the decision is supported and not supported. So I would recommend those who are reporting report on hypothesis testing to show your decision of your data analysis, whether the hypothesis is supported or not supported. And then look at the H2, for example, here from perceived flow to customer satisfaction. The score is 0.407. So what you can say here, is it a positive or negative relationship? It is represented by positive relationship, meaning perceived flow has a positive influence or positive effect on satisfaction. How do you know positive? Because the beta value is positive. If the beta value is negative, we can say there is a negative effect. And then when we want to say whether the effect is significant or not, we take a look at the t-value here. And the t-value must be higher than 2.58 in this study. How do we know 2.58? Okay, this is the critical value that I've shared with you just now. 2.58 is here, represented by this figure, meaning the author have used a two-tailed test. And then it is a significant at 1%, 0.01. Similarly for H3, look at it, from the perceived flow to purchase intention here. This is the perceived flow. This is perceived flow, and this is the intention. And then the beta score here is 0.345. 0.345 meaning positive, right? Because the value should be ranging from -1 to +1, meaning this is positive 0.345, meaning the relationship between perceived flow to purchase intention is a positive relationship. And then is the relationship significant or not? We'll take a look at the t-value. T-value more than the critical value of 2.58, meaning the relationship is significant. The effect is significant, and that's why we put it here as supported. Okay, and then last one, customer satisfaction. Look at here, customer satisfaction, the price coefficient 0.376. That is also positive, meaning customer satisfaction has a positive effect or has a positive influence on purchase intention. We can say the higher the customer satisfaction, the higher the purchase intention by the customer. And then the effect is also significant because t-value is higher than 2.58. So this is how we present the results of the analysis to show the relationship of the variables or construct from one construct to another, and whether the relationship is significant or not. Therefore, for students, if you want to read any paper reporting on a PLSM result, because when you develop your own framework for your research project, normally when you have your framework, there will be an arrow, right? From one construct to another construct, one variable to another variable. And this arrow represented by the hypothesis. For example, here, hotel website quality to purchase flow, there will be one arrow here. Meaning you want to say in your framework, hotel website quality has the relationship or has the effect on perceived flow. So that is why in this study, the hypothesis here show that hotel website quality have the influence on perceived flow. So whenever you want to develop your hypothesis, that hypothesis must be supported by three things. One, it must be logical, supported by logic. Is there any logical explanation saying that whenever the website is good quality, there will be a good perceived flow? Perceived flow here meaning you are meaning concentration, in terms of concentration, in terms of your immersive, in terms of you immerse in using the particular website. Unlike when you watch a movie, when the movie is good, in terms of perceived flow, you will be enjoying it, you will be flowing with the movie. Meaning sometimes you do not know what happened around you. That is meaning a perceived flow. Similarly, for when you are playing games, for example, computer games or mobile games, for example, when you are concentrating with the games, when the application is so good, you are flowing with the apps, meaning you don't know what happened around you. So if you happy with the quality, the website is so quality, because some hotel website, it has very interactive features, like virtual reality, 360 video. You can see the hotels, the condition of the hotel, how the room is look like, how the lobby is look like by looking at the 360 video. As maybe by using these features, you'll be flowing around with the website, meaning that's how the website quality influence perceived flow. And if you feel like that, it will increase your satisfaction as user of the website, and then it will increase your intention to purchase or booking the hotel through the website. So let's say if you want to develop your own framework, whatever construct that you use, so it need to be supported. For example, if your study also talking about the influence between, let's say, between satisfaction and purchase intention, meaning in your study, you want to know a customer who have used, let's say, online, let's say, e-hailing service, for example, Uber, Grab, for example. For the customer who have used e-hailing services, you can ask them in the questionnaire survey to measure their level of satisfaction and their level of repurchase intention, for example, to reuse the e-hailing services. So you want to say that people who are satisfied using e-hailing services has the intention to reuse e-hailing services. So let's say that is your model, simple model. So in order to support that model, must be supported by theory. So you can use, for example, in this theory, it is use stimulus organism response theory to support the link between every single construct here. And then other than theory, I show you the three just now. Logic, it must be logic. Every single relationship must be logical. That is number one. Number two, must be supported by structural theory. Is there any theory that you can use to support the relationship? Because theory can help you to explain why IV relates to DV, why one variable relates to another variable. And the third things, other than logical, it must be supported by theory. And third things, it must be supported by empirical evidence. Is there any empirical evidence? Empirical evidence means past studies that has found the significant relationship between the construct that you want to measure just now. For example, in your study just now, you want to measure e-hailing customer satisfaction to repurchase intention. So when you want to develop your hypothesis, you want to say e-hailing customer satisfaction can influence or have a positive influence on repurchase intention of the e-hailing services. So how do you know that the satisfaction and purchase intention or repurchase intention will be positive? Because hypothesis is just we call it our prediction on what will happen, prediction on what the relationship will be. Is it the relationship will be positive or negative? How do you know the relationship or the effect will be positive or negative? It will be supported by the past literature or past finding from previous study. So when you read PLSM paper, for example, you want to develop your hypothesis, you want to say whether e-hailing customer satisfaction can influence or not their repurchase intention. So the hypothesis, you want to say customer or e-hailing customer satisfaction has a positive or negative influence on purchase intention, for example. So if you want to have to say positive, so what is the evidence or why or what is your justification to say the effect will be positive? So you can, when you know already how to read PLSM paper, you can just take a look at the here, take a look at the beta score. For example, here from customer satisfaction to purchase intention, the beta score is positive because it is 0.376. That is a positive. Positive means it has a positive effect, and this effect is also significant. So you can say, based on this study, from this paper shows that customer satisfaction influence has a positive effect or positive influence on purchase intention. Therefore, in your hypothesis also, you can say therefore the following hypothesis is developed. So you can say the e-hailing customer satisfaction can influence purchase intention. How do you know? How do you know the hypothesis is positive? Because you based on the previous studies. Okay, so I think in this time already, we don't have much time to look into some other example from other papers, but I hope after this, especially for students who are doing undergraduate research project, so it can help you to read at least PLSM papers on how to use this information to support your study, especially in developing your hypothesis and to justify every hypothesis that you have developed. Then I think that will be the end of my presentation. And this is my contact information, my contact number. You can WhatsApp me if you have anything to discuss. And this is my email address, and this is my research profile. Therefore, once again, I'd like to thank for the organizer that have invited me for sharing in this session. And thank you also for everyone who have participated in this session. Thank you very much.